Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
NASA is working towards a sustained human presence on the moon, which is presenting some interesting engineering challenges. One of the people working on the concepts and solutions for making that human presence a reality is Goncalo Esteves, founder and CTO of Argo Space Technologies. Goncalo, welcome to the Terra podcast.
Tom, thanks for having me.
It's my pleasure. Tell us, first of all, about Argo Space Technologies and what it is that you do.
Well, what I'm delivering is fast-paced solutions for people that are building things for space. And I mention building. I don't only mention design. So Argo Space Technologies is a combination of lean, systems engineering, agile methods, infused with, I believe it's the best knowledge out there regarding space. And I advise companies on how to execute their processes, how to increase the speed of delivery while maintaining an extremely high standard.
You know, we hear a lot about lean technologies and that whole lean concept. What does that mean?
Oh, Tom, if you go by the book, lean, it's a way to deliver with minimal waste to your customer. By the book. There are 5 principles. Essentially, what it means is when you walk into a place that is a lean place, you see things organized and flowing faster, flowing really fast. And at the end, let's say that this was the first stage, okay? You see that the first stage meets expectations, meets the quality requirements. If you go a bit more into the next systems, if we're talking about a rocket, you'll see that the range officer will not stop the rocket. Okay,
that's a good thing.
Then I believe that what I've seen regarding the lean philosophy, it was not fast enough.
Mm-hmm.
That's a fairly good comment. And we moved more into the experimentation realm with methodologies such as Agile and some variations on that. Now they are called Scrum. But to be fair, they were invented in the 60s. Mm-hmm. with, or at least many of the things were tried in the 60s, while the US and even other countries, but mostly in the US for the space community, was really making Apollo come alive.
And so you've said you want to make things faster, ready, and better. What do you mean by that?
Yeah, if you go back to the literature on space, there was a time when NASA tried to do this. They would say, let's do faster. They even said cheaper and better. But the combination of cheaper means probably cheap materials. And from first principles, cheap materials usually don't work that well. Mm-hmm. We need to have the right materials and ensuring that that we deliver. So what I mean by this is the following. If I put myself in the shoes of an entrepreneur or someone like myself that is essentially trying to build the next moon mining rovers, we know that the first prototype will not work. We know that.
Right.
So what that means is that we'll build each one of the modules in there with generic configurations, with enough interfaces that if I can build the wheels, and I can build the hopper, and I can build the electrical system, and I just focus on the system itself. And I don't, for now, I'll forget the interfaces because they are standardized. I will evolve much faster on first the subsystems and then in the interfaces. That's why you see Starship having many numbers, serial numbers. Mm-hmm. They are just evolutions of each one of the subsystems, and then they get stacked together. And that's a fundamental difference when you think about long-term prototypes or things that take a lot of time. So faster means, okay, I need 5 major prototypes for something that they will integrate with this within this each if each one has manually 5 subsystems, and over time, this is important because over time the delivery gets faster because, okay, I iterate, I test one, and in my previous work, we tested a ton of stuff. Some of them didn't work. That's the reality. And immediately, you've got something immediately before that. It is just a little bit better. And that a little bit better might be the solution for your problem, or it might not be. The hard part in there is if I'm an investor and I'm not prone to risk, I was like, these guys failed again and again and again. So coming back to someone that said that the rate of innovation is really the only thing that we need to be concerned with. But we need to have the money for that. So that's why putting these out there immediately, Tom, putting these to the investors out there, even if the investors are your family and friends, right, and some of the NASA money that comes out of the challenges, putting these out there and saying, this is our approach to risk. There is a good belief and data, okay, really important. There is data that this approach over time makes you faster over time.
You know, there's an old adage in business where people will say, you know, it's good, cheap, fast, pick any two. How do you work around that kind of a concept? Is there a way to do things where you can get all three? And by cheap, I mean at least cost effective.
Yes, until I would say, and I go back to a combination of things, until the literature in the 80s, okay, around PMI, Project Management Institute, they would say that the triangle of project management was impossible to be broken. That is, you cannot have something that is cheaper, faster, and within scope at the same time. If we look into companies like, okay, we have to reference it, Tesla and SpaceX, it is possible. It is because you iterate extremely quickly on things that are not working. And we've seen clearly that in the beginning, the challenges are immense. But as you move forward, either because, okay, you look at the requirement and it's dumb. Why should I have rectangular surfaces on rockets? Doesn't make sense. It's extremely hard to ensure that the propulsion mechanism is evenly distributed. Oh, that's why they turn into circle. Okay, cool. Correct? It's a first principle thing. And then you go back and you look at, okay, what are the components and materials that are in here? Oh, okay, probably too much components. Components means complexity. Can we reduce that? Okay, we've done that. Let's go back again. And what are the materials that exist in here? And someone would say, oh, it's impossible to get something like a carbide. Think about, in my case, so it's impossible. Okay, is that really impossible? That's where you get the lean concept. That is, you go all the way back to the supplier and all the way back to the raw. Is that really impossible to make these less expensive? So when we start using that, I believe it's possible. In our case, in the company that I've been supporting for the NASA Break the Ice challenges, we found a company that does remote controlled rovers at a smaller scale, but it actually fit because a vehicle on the moon or on Mars will have X amount of wheels or something that moves, but that thing moves in this direction. It doesn't hop yet.
Right.
So that thing will not change, correct? It's physics. So I think it's possible. We just need to go really step by step, and there is a methodology, then that's what we bring to the companies.
You know, you mentioned SpaceX, and Elon has often said that he expects to blow rockets up. He learns from that, but he said, we're going to launch, it's going to fail, we're going to learn from that, and we'll make a few changes, and we'll launch again, and eventually it'll work. Is that a concept that works well across other industries, or is it just someone like Elon Musk who has fairly unlimited resources and can afford to do that?
Okay, so I'll tell you a story. It's called the Frankenstein Story.
Okay.
When we opened up the Brazilian plant for Jaguar Land Rover, a couple of years ago. I was in that process team defining the whole blueprint across the world. So how are we going to build things across the world in a standardized and faster way? And you just need to look at the requirements, sir. And we built something that we called Frankenstein at that time. That was a vehicle that had several parts that meet specifications, okay, to the regulator. It's also important because, as well as Elon Musk, everyone is subjected to some kind of regulator.
Right.
The battery was from one type of vehicle. The headlights were from another. They all meet specifications, okay? And the result was, by this date, you need to have something that is sellable, meaning, okay, everything in here will not kill anyone. And we did it. Okay, the battery was not exactly on the same location as expected. In fact, we had it outside of the vehicle. But it worked, and it did all the required tests. In this case, it didn't do the water testing tests because they were not needed at that moment, okay? But it met. We had a battery that was not from there. We had headlights and bumpers that was exactly like what was intended in the beginning, and in this case, the Brazilian government had to see that. So that works. You do need to look at what is in here and it's needed, and then from there, and then work backwards from that. What you are asking is everyone ready for that? No. The answer is no. The answer is most likely no, because there is this need either of one, and it comes from my experience in the also in the space companies, but also in the banking industry. It's kind of curious. A second story: a space company always, the ones that are on the SEC, on the stock market, man, the amount of eyes that people put on them, it's unbelievable. It's really, you need to be prepared for a level of reporting and a level of transparency that is extreme, okay? Sometimes risk-taking and investor looking into that, they don't follow the same path, okay? So what I mean by this is, we took that risk, and I've taken a couple of other interesting risks in terms of design and changing things or using things. It requires someone that supports you in the team. It requires also that the levels of supervision are reduced to the minimum, and the levels of responsibility are increased to the maximum. That's what it requires.
You know, it sounds like you've had a very diverse background. Tell us a little bit about that background and how you wound up consulting with space companies.
Oh, okay. Man, Tom, that's a good one. Yeah. So before COVID, I had this incredible opportunity to work. I worked at Honeywell as one of their, I'm going to say, lead consultants in changing the company into a digital process blueprint. And COVID hits, and my son asks me, "Hey, what do you want to do when you are a grown-up?" That's a pretty terrible question, isn't it? You cannot say, at least I couldn't say from my heart, like, I'm going to be a consultant in business process management doing whatever it takes just to earn money. That's not a life that you can bring anyone into. It's impossible. And I had this dream back in Portugal that I want to be an astronaut. Mm-hmm. So I talked with Simon Gessner from Axiom. I was like, "How much do you want?" 55 million. I was like, "Nah, man, that's too much money." and then I did the space course in Florida with Greg and with Greg Autry and Aldrin. Mm-hmm. And those 15 days changed a ton of my perspective on space. But back to your point, I said to my son, I want to be an astronaut. And I want to inspire others that are willing to do the work to do the same, because that's the place where if we do the work, we will get, confronted with our own beliefs, my own difficulties in life, in doing things. And we'll be able to, if I can get it, man, others will, and many will. So I'll open up the way. So they kind of tagged along with this idea that, okay, how can I not pay 55 million? That was one of my things.
Mm-hmm.
And how can I do that? So I look at some statistic numbers like, okay, if I work for a Blue Origin or SpaceX, the probability of becoming an astronaut, or Axiom, or a couple of them, the probability of becoming an astronaut, that is like 700 people divided by X amount of billion. It's a terrible probability, correct?
Right.
If I work for one of these companies or I provide services end to end, my probability increases like 100-fold. Fine, that's what I'll do. Since I've been working hard in many industries, from regulatory to water and waste management, stuff that no one likes, but they're really important, like,
Right.
oh, okay, that's my rule. I'm going to help companies in the US build up their space framework. At the same time, I'll start designing, testing, building, and flying them and get back home. So that's kind of that's what motivated. Like, no, I can take my skills and help others to reach space, and therefore bringing more jobs into the economy, and also bringing other generation. Like, space is for the young. I get very annoyed with that thing. Man, no, space is for everyone and for all the ones that want to put down the work. So that's what I did. That's why, as we moved to the US after me and my family being in Portugal, Norway, UK, Brazil, and being the US our live dream, it's like, okay, this is the spot. No longer, don't waste any more time.
I think that
that's it. That's what happened.
I think that anyone who thinks space is for the young hasn't heard that William Shatner got to go to space at 90. But
yes, yeah. And in fact, after I've taken that decision, when COVID hit, I contacted everyone that I knew in my, mostly because of course, I knew I'll work in aerospace. And I went into all the AIAA forums and I said, here is someone that is ready to work.
Mm-hmm.
Let me know what you need. I sent 635 emails. 2 persons got back to me, 2 of these groups. And one of them is in the AIAA Space Operations Technical Support Group, where I'm the vice chair of commercial space. It's a lot of words, but essentially I help organize the meetings and help bringing the knowledge of people from NASA space centers into commercial space companies. And because of that, and because I've attended everything that was possible during that year, I assembled the first team to go for the NASA Break the Ice Challenge. I've reached out to Clive Neal. Clive Neal reached out to Paul Van Zante, and then from Honeybee Robotics, Hunter, and we assembled the first team. And I was like, man, let's go and do this. I think this is an opportunity. I helped assemble that team. Paul has a fantastic team in MTU, and we delivered the first design end to end, and we got that first award. And then after that, I started working more in space. I worked at Astra, and then after Astra, I moved to support Planetoid Mines doing exactly the same. And that's where we got the first prize and award to build the moon rover. So it's been like and the probability of that, I've made the probability of me even getting a project in space was 0.47%. I said, that's fine. That's something that I can live with.
I want to talk about Planetoid Mining and the Break the Ice Challenge a little bit, because we were initially introduced to your work with Planetoid Mining and the Break the Ice Challenge. And so let's talk about, first of all, what is that Break the Ice Challenge?
Okay, so NASA has got this fun way to I think someone at NASA said, like, how are we going to source concepts and innovation in the maximum effective way with the least amount of money? Let's put down a challenge. And this is part of one of them. This is how NASA sources innovation ideas. In this case, for Break the Ice Challenge. The point of the Break the Ice Challenge is this: sooner or later, we'll be on the moon. But being on the moon, and remember that Artemis talks about sustainable presence on the moon. Sustainable presence needs to exist. For that, we need fuel and water. Makes sense, correct? Life equals water, fuel equals transportation. The moon has, in particular regions, mostly near the PSRs, permanently shadowed regions, locations where there are ice crystals, water ice crystals. Okay, it's really cold out there, okay, really cold. So NASA put up this challenge. The first phase of the challenge was show me an architecture that is able to extract regolith and transport water ice crystals. We got that one done. Really interesting. The second phase is, okay, since you guys have done the first one, now build a system that is able to excavate that regolith, okay, and bring it from point A to point B within a certain reliability. Something never done. 15 days on Earth, no touching, and something that NASA was very fun on this. They call it durability. That is, you cannot touch the thing. It needs to be running in 15 days without touching. And that's a very interesting challenge, because if you think about the Apollo astronauts, they were there, worst case, equipment-wise, 2 days, okay? That's it. Or better case, and NASA is now asking us to be there for 15 days, no touch.
Right.
That's a very interesting challenge, Tom, and that's a challenge that we are tackling step by step.
So, how is Planetoid Mining addressing those issues? What are the technologies that you're working on developing?
The excavation is done via bucket drums with counter-rotating forces. That's I would say, different from the ones that you've seen in the swamp works, but they follow the same principle. We need to excavate something from the ground, because we have low gravity in there or zero gravity. We need to find a way that we are able to pull up things. And then in this case, we have a conveyor belt that brings the existing regolith and this is a cool part, into a closed container that will maintain the properties of the regolith as we then move it along the right traverse, and then deliver these into what will be the NASA water ice transformation plant, something that is still on the books. Okay, the process is known, it's not on Earth, but the way that we are addressing is we have Planetoid Mines in this case has a technology that is pending patent and it was filed to excavate the regolith and transport it, and so that's coming up nicely. Right now, we also found again a very non-expensive way to test these. How? Kevin has with the support from Rio Tinto, sorry, not from Rio Tinto company, but in Rio Tinto region, he has the support of the local authorities, and we found a place that is similar to the moon. You know, the granular, the soil is. Man, we did the simulant and we did the moon. The moon soil was like, wow, this is it's very similar to what we'll find on the moon. Even the temperature difference is not, but it's overall the traverse, the soil, the location itself. It's a bit of the moon. So our team is not spending any money on buying simulant, or we're going to a place on Earth in the US where people are interested to say, okay, test it in here, and that's pretty cool. You see what I mean? So it's very low tech what we are doing, because we understood the geological needs for this part of the challenge.
I'm talking with Goncalo Esteves, founder and CTO of Argo Space Technologies, on the Terra podcast. Take a moment right now to click subscribe to be sure you don't miss any of our podcasts, or if you're watching on YouTube, any of the videos from Terra, the Journal of Space Commerce. Goncalo, you've worked on business processes for the International Space Station as well. What have you been doing with that?
Oh, sir, that was a fun project. That was after so the International Space Station did something very similar in the same spirit. Okay, how are we going to pick up something that costs a lot of money every year to the ones that pay taxes, to everyone?
Mm-hmm.
How are we going to change that? Can we make it a profitable thing? That was the question. Can we make it? What are we going to make it after 2026? So I was part of the World Design Organization team that looked into the ISS as an end-to-end. And I stayed with the business process side. And that was my opportunity to map out end-to-end how a company can put an experiment in the ISS, okay, end-to-end. And that was like a big eye-opener because I could see all the forms that are needed, all the due diligence, all the experiments, both on Earth and also in space. What do the astronauts do? And then how do you return those things back to Earth? And then how do you know that whatever I did in there has some benefit for humanity? So I work on the whole end-to-end post the World Design Organization Challenge. And it was clear for me, right now it's a 3 years, most of the cases, a 3 years process. So think about this, Tom. If you have a problem and you say, okay, I believe that this crystal can be produced in space because there is no gravity. We might find other geometries to help something. Let's say a new eye product. You need to wait 3 years to put something up there.
Right.
It's incredibly long. Me and a set of people from the ISS, that was pretty cool. We went step by step and with some improvements with the existing technology and hardware, we could move it to 6 months. That's also meant that we could increase and we could even triple the capability of projects that were being intake. That would be the intake. Some data exists right now saying that the ISS got to their maximum capability. I was like, what do you mean by that? We have room for more people if we fly more and come back more. So I think there is a need for more invention in there because the data that I've got really tells we can move that process to 6 months, that is end-to-end. And we can make that not a cost center, but a profit center overall. That was pretty cool. Like that was one of my first move from the world of business process corporate to space. That was those recommendations were proposed to the ISS, and I believe they were in a report that was later on addressed in some of the congressional sessions. That's where it stayed. Essentially, great experience to know how the ISS works inside out.
You were also with the AIAA working on the Commercial Space Operations Subcommittee. And for those that don't know, what is the AIAA and what does your subcommittee do? Oh, so the AIAA is like an extensive group of people. It's the most welcoming group. The American astronauts, I think we need to make sure that let me confirm to make sure that I give you the right nomenclature. American Institute of Aeronautics and Astronautics, okay? And this institute has many professionals from space, people that give their time to help others build their space careers and the space knowledge. It's very much like the INCOSE, International Council of Systems Engineering, where people from a whole set of professions and sectors say, what are the best practices to do this? In this case, that's where I learned about passivation methods, conjunction analysis, methods for mission management. And essentially every year, this group publishes a journal, the Journal of Space Operations, that picks up what we believe and we try from the members what is best in academia and brings this to the commercial space arena and in reverse as well. So what my role has been, I need more people from commercial space to ask academia, what do you need? So that this cooperation occurs. And Tom, I've seen fabulous work that we as taxpayers pay to
to many of academia works and centers within NASA that when I worked as a consultant for space companies, like, you guys need a software that does space mission design? It is something that you can be helped with, because we as a community, as an overall country, invested on that. So use it, please. It might not be perfect, but it definitely got you a head start. So that was, Tom, that's been one of my main challenges, that there is a ton of knowledge in this AIAA SOSTC, Space Operations Technical Support Group, and the other many groups. And the word is how do we percolate that knowledge into new space companies and even into existing space companies, and then the reverse. So think of these groups as accelerators, or at least they need to be accelerators of the space economy. And also places where you are welcome to go there and help and get trained, because when you do things, you get trained and get contact with space. It has the natural challenges. The work is not paid. Well, depending on you think about payment, but you work for the community. I think that's really important to say. And in the US, we are all very much profit driven, but there has to be something major. Like, we are here to help others in their space mission. That's what I do there, to be fair.
Process engineering, it occurs to me, is becoming more and more critical as systems become more complex. And you mentioned about the education aspect of it. Are you seeing that young engineers are coming out of school with the right kinds of skills to address these complex challenges?
I've seen two completely different realities, okay? One of them is engineers that I've met as working in some of these space companies that left. I'll give you examples. From New Jersey, moving to California and starting working on valves. And these guys and girls these people have hands-on experience. They start doing it. And then I've seen in the academia world, because over the years I keep on going to learn. That's my last following the Space Tech and Loyola Montoya University, both in, and I've seen in there a combination of, and it has to do with the student, okay, and probably with the teacher, okay. But do I want to do this, or I'm just here for the grade? It's so evident, sir. It's so evident. Like, oh, this person is here really because he wants to build that part of hardware, or he wants to work on the software. Well, okay, I got this one because it's in my curriculum and I just need to do it. So I think right now it's a combination. It is clear for me, and I made an analysis during the last years, that the US needs people from the trades space, CNC mechanists, welders, better chemists, people that are able to move and execute, and they also have technical knowledge. It's very clear that part is missing. We had tons of, across the board, when I started consulting, most of the people would say to me, Goncalo, what I need is a replicable process so that I can infuse the knowledge that we have in new people that are coming. And I had this a ton of times as people, for example, increase the size of their facility, or they just add another capability. If they move from, okay, right now I'm going to have a new machine that will work with 3 axes or 4. It's like, we have someone that knows that, but he's about to go to another company. We haven't captured that. What are we going to do? That's happening. The other thing that I've been really watching is there is a lot of requests for people that are knowledgeable of human space flight, but to be fair, they don't exist. That's, you might write in your resume, I did human space flight, but if you want to be real, the last human space flight was the shuttle missions, and then SpaceX.
Right.
I'm going to put SpaceX to the side, because whatever is happening there, it will be independent of all all of what the others are doing. And to be, well, I think in a couple of hours, you'll have the static fire test, the hot fire test for the 33 engines on Starship. So that company is going in a speed, and the concept that I want to give, since we are kind of blurring around, in space, there are levels of speed. SpaceX is in another ballgame, in a game where they have their own space program. This is really important. Whilst, and this is so controversial, then I'm going to say the other tier of speed as an overall space program aligned with NASA. Then there are others that are trying to find their own space program. And you might ask me, where are you, Goncalo, in these three? Well, I'm building my own space program. I don't believe we should wait. We cannot wait. The time will run away. So these three levels and these three speeds, and can put names to this, and you can even characterize that. There is a nice exercise that is you dump the website of each company into a word cloud for their job specs, and you organize the levels of recruiting. And I did that between SpaceX, Blue Origin, Rocket Lab, and I understood how many layers exist in the organization, sir. And that was an awesome thing. Like, oh, okay, if I work in there, I will understand that it has 3 layers. In here it has 6. In here it has 4. And I was like, okay, we know that the structure of hiring equals the structure of the organization, therefore the structure of the product, because therefore the structure of the system, correct? This is how things are lined up, because people hire based on the thing that they have around you. They don't invent something. And then you see which one is going faster and which one is the structure that allows you to go faster. Or where do you want to be? So that was a very interesting analysis that I did, like, oh, okay, these guys will take 7 years to get there, 7 to 10. These will take probably 3. So, yeah, again, that comes from the consulting work where you need to quickly understand. But for us, Tom, for the U.S. space economy and for what we need to do, we need to move faster, sir. We need to be able to build our own space program, and I believe we have the means.
And so we're just about out of time, but I want to ask you kind of our standard exit question, and that's to look out, if you will, over the next 10 to 15 years, thinking about space commerce. Tell me what you see.
I see a clear proliferation. I see a clear highway in the cislunar economy emerging, very clear. It's not yet completely clear to me who will be the major player, at least in cislunar economy. I see a huge event happening regarding space sustainability and using the Space Sustainability Index. But I also see that if you look into the propulsion mechanisms, we are, I would say, 5 years next, if this even happens, we need something that gets us to Mars and Europa and faster. So I see that coming up. I see big investment in propulsion systems and the highway happening in the cislunar economy. And of course, I see our rover there. That should be cool. And I see also that the companies that are at tier 2 need to catch up, because if not, they will run out of funds. That's the reality. No one will buy a car that is 15 times more expensive than one that is already working.
Yep. Very good. Goncalo, thank you very much.
Okay, Tom, thank you very much. Thank you for the opportunity. It's amazing that you guys share these experiences. There are amazing people out there doing space, and I'm grateful for being and helping others.
Goncalo Esteves is founder and CTO of Argo Space Technologies, and thank you again for being our guest on the Xterra podcast. That is going to do it for this edition of the Xterra podcast. You can subscribe to the audio version of the podcast on Spotify, Apple Podcasts, and many other popular podcasting platforms. Be sure to click on subscribe so you don't miss an episode of the podcast or any of our other videos. You can also get daily space commerce news at xterrajsc.com. And one thing more, be sure to connect with us on LinkedIn and follow us on Twitter at xterrajsc. Until next time, I'm Tom Patton. Thanks for joining us.
I wanna go faster, faster. Hands in the air, we're gonna crash. Searching for the answers, my Galileo through his looking glass. Thirst for reason, our dreamer's eyes we gaze into a sense of purpose, know my view. Like finding water on the moon.